Hello everyone, welcome back to the course on Computer Fundamentals and Problem Solving using C. This is Saroja Patapati, working as Assistant Professor in the Department of Computer Science and Engineering, SRKR Engineering College. In this session, we are going to discuss about the types of data available in our C language and what are type modifiers and how we make use of them. Coming to the objectives is to learn about various data types and type modifiers in detail. What is a data type, right? It is nothing but a keyword which is used to identify the type of data. Whenever the user want to give some input to a program, right, he can give some whole numbers, real numbers, characters, strings or anything. But we need to differentiate between these things, right? Whatever the constants that we are giving, we need to differentiate the type of that particular thing. So that is known as a data type. It is majorly categorized into three types. They are primitive data type, derived data type and user-defined data type. Character, int, float, double and void. This will comes under a primitive data type. Whenever we create a variable using this data type, it will store maximum one value at a time. So if you see an example, int a, yes, it is valid. If we store a single value into this variable, even that is valid. But here, I'm trying to store multiple values into the variable a using primitive data type. So this is not valid in C language. Okay. Coming to the derived data types, array, pointers and function. This comes under derived data types. Whenever we create a variable using this derived data types, it allows us to store multiple values. But there is a condition that values must be of same data type. Okay. If you observe the example here, I'm trying to store 3 integer values into a variable a. This represents an array. It is valid using derived data types. But if I try to store multiple values of different data types, it is not possible using derived data types. Coming to the user-defined data types, here we can store multiple values of either same data type or multiple data types. So the examples for this are enumeration, structure and union. Here we are taking an example for structure. Right. Here I am trying to store different data type values. Yes, it is accepting different data type values. And if you look at here, I am storing same data type values of 10. Right. Even this is valid using user-defined data types. So coming to the difference, in primitive data types, we can store maximum one value at a time. In derived data types, we can store multiple values, but the values must have same data type. And in user-defined data types, we can store multiple values either of same data type or different data type. Coming to primitive data types, okay, integer, float, double, char and void comes under primitive data types. And integer is meant for storing some whole numbers like 0, positive values and negative values. So the memory required for storing an integer value is 2 bytes. Fine. But in your compilers it is taking like 4 bytes. What is meant by a byte? 1 byte is equal to 8 bits. Okay. So what the machine code consists of zeros and ones, right? If you want to store either 0 or 1, you need 1 bit of memory. Right. So a group of 8 such bits is known as a byte. Okay. Then coming to float and double, they are used for storing some real numbers or floating point numbers. Okay. As both are used for storing the fractional values. What is the difference between them is float requires 4 byte of memory, whereas double requires 8 byte of memory. Fine. Characters, it is generally used for declaring a character. And whenever you declare a character, it must be enclosed in single quotes and it requires 1 byte of memory. Void means there is no data type. Fine. But this is not applicable to variables. This is only applicable to functions. Coming to type modifiers, right? These are the keywords which changes the property of our data types. That is, we can change the property of data types using these type modifiers. These are majorly categorized into 2 types. They are size modifiers and sign modifiers. Okay. Long and short will come under size modifiers and signed and unsigned will come under size modifiers. As the name suggests, Okay, if you observe here, as the name suggests, the size modifiers will change the size of the data type, whereas the sign modifiers will allow or restrict you to store either positive or negative values or both, right? So let us see long. Whenever you use long, just precede it to your data types, right? Whenever you precede your data type with long, the size of it will get increased by 2 bytes. Okay, so if you use like long int, then the size will be 4 bytes. Generally int will occupy 2 bytes. If you use long int, it will occupy 4 bytes of memory. Then coming to a short, it will allow you to allocate a fixed size of memory, right? As we are discussing, different compilers will take different amount of memory. Short will allow you to fix some fixed amount of memory, right? So if you use like short int a, it will generally occupy 2 bytes of memory irrespective of your compiler. Okay, then coming to unsigned, this allows you to store only positive values. Okay, if I precede this int with unsigned, fine, it will allow you to store only positive values. So declaring 100 is correct, but if you declare like negative value of 100, it is not acceptable using unsigned. Fine, if you precede any data type with signed, right, it can accept both negative and positive. If you precede signed to any data type, fine, it is very much similar to just like int and signed it, both are same. Okay, so here we are giving a note, like in real time there is no need to include signed keyword. If you include it or not, it will by default take the signed keyword. Okay, here see, this size and sign modifiers are applicable to int, right? Size and sign modifiers are applicable to your integer value. That is, you can declare int like short int, long int, unsigned int, unsigned short int, unsigned long int, signed int, unsigned long int, signed long int, and signed short int. So these two modifiers are applicable to integer. Okay, and these sign modifiers can be applicable to characters. That is, you can write like unsigned char or signed char. And double will make use of this long. To float we cannot use anything, right? So double can make use of this long. So if you observe the table here, you can clearly understand. So for character we can use sign modifiers, that is signed and unsigned. For integers you can use both of them, that is sign modifiers and size modifiers, right? Here short means it is short int, unsigned short means it is unsigned short int. Okay, and you can use long for double. And here in this table we are giving like the size and the range and what is the format specifier for our particular data type. Coming to character, it will occupy 1 byte of memory, that is it requires 8 bits, right? And it ranges from -2^7 to 2^7 - 1. Because remembering digits is really a difficult task, so here I am representing it with in powers of 2. Fine, it makes us easy to remember. So character will ranges from -2^7 to 2^7 - 1, and the format specifier used for character is %C. And then we are using unsigned char. It will also occupy 1 byte of memory, and it ranges from 0 to 255, that is from 0 to 2^8 - 1, and the format specifier used is %C. For short int, it will occupy 2 bytes of memory, and this is the range. We will represent in powers of 2, that is -2^15 to 2^15 - 1, and the format specifier used is %D. Coming to unsigned short int, it will also occupy 2 bytes of memory, but it will only take positive values. So it ranges from 0 to 2^16 - 1, and the format specifier used is %U. Coming to int, it will occupy 2 bytes of memory. It ranges from -2^15 to 2^15 - 1, and the format specifier is %D. Then unsigned int, it will occupy 2 bytes of memory, but it will take only positive things, right? So 0 to 2^16 - 1, and the format specifier is %U. And then long int will occupy 4 bytes of memory, and it ranges from minus 2 power 31 to 2 power 31 minus 1, and the format specifier is percentile LD. And unsigned int, it will occupy about 4 bytes of memory, as we have preceded it with unsigned long int. So it will occupy 0 to 2 power 32 minus 1. It will take only positive values, and the format specifier is percentile LU. Then float, it will occupy 4 bytes of memory. We will represent this in the form of exponential. So here we are taking from minus 3.4e minus 38 to plus 3.4e minus 38. And the format specifier is percentile F. Coming to double, it will occupy 8 bytes of memory, that is from 1.7e minus 308 to 1.7e plus 308, and the format specifier is percentile LF. For long double, it will occupy 10 bytes of memory. If you observe, whenever you keep long, that is whenever you precede the data type with long, the size will be incremented by 2 bytes. Okay, and it ranges from 3.4e minus 4932 to 1.1e plus 4932, and the format specifier is percentile LF. So this is the end of the session. In case of doubts, you can text me, and we will see in the coming sessions.